Welcome back to the Network Plus training series. In this lesson, we are covering Objective 2.2. Given a scenario, configure switching technologies and features. Switching is the backbone of local area networks. Understanding how switches operate and how to configure their features is essential for the exam and for real-world networking. Let's dive in. A network switch operates primarily at layer 2 of the OSI model, using MAC addresses to forward frames to the correct destination port. When a switch receives a frame, it examines the source MAC address and records it in its MAC address table, also called the CAM table, along with the port on which it was received. When the switch needs to forward the frame, it looks up the destination MAC address in this table. If the destination is known, the frame is sent only to that port. This is called unicast forwarding. If the destination is unknown, the switch floods the frame out all ports except the one it arrived on. Let's start with VLANs, or Virtual Local Area Networks. A VLAN is a logical grouping of switch ports that creates a separate broadcast domain. Without VLANs, all ports on a switch are in the same broadcast domain, meaning a broadcast sent by any device is received by all other devices. VLANs allow you to segment the network so that broadcasts are contained within each VLAN. Devices in different VLANs cannot communicate directly. They need a layer 3 device, such as a router, to route traffic between VLANs. VLANs provide several benefits. They improve security by isolating sensitive traffic. They reduce broadcast traffic by limiting the broadcast domain. They provide flexibility because devices can be grouped logically regardless of physical location. And they improve performance by reducing unnecessary traffic. Each VLAN is identified by a VLAN ID, a number from 1 to 4094. VLAN 1 is the default VLAN on most switches and should generally not be used for production traffic. When configuring a switch port for a VLAN, you assign it as an access port. An access port belongs to a single VLAN and is typically connected to an end-user device like a computer or printer. Trunk ports are used to carry traffic from multiple VLANs between switches or between a switch and a router. A trunk link tags each frame with the VLAN ID so the receiving switch knows which VLAN the traffic belongs to. The standard trunking protocol is IEEE 802.1q, which inserts a 4-byte tag into the Ethernet frame containing the VLAN ID. The native VLAN is the VLAN whose traffic is sent untagged on a trunk link. By default, this is VLAN 1. Inter-VLAN routing is the process of routing traffic between VLANs. Since VLANs create separate broadcast domains, a layer 3 device is needed to forward traffic between them. There are 3 common methods. The first is using a traditional router with a separate physical interface connected to each VLAN. The second is router on a stick, where a single router interface is divided into sub-interfaces, each configured for a different VLAN and connected to a trunk port on the switch. The third is using a layer 3 switch that can perform routing internally between VLANs using switch virtual interfaces, or SVIs. Spanning Tree Protocol, or STP, is a critical switching technology that prevents loops in networks with redundant paths. Without STP, frames could loop endlessly in a switched network, causing broadcast storms, MAC address table instability, and ultimately a network outage. STP works by electing a root bridge, which serves as the reference point for the tree. Each non-root switch determines the best path to the root bridge and blocks redundant paths. Blocked ports do not forward traffic under normal conditions, but can be activated if an active path fails. The original STP, defined in IEEE 802.1d, could take 30 to 50 seconds to converge after a topology change. Rapid Spanning Tree Protocol, or RSTP, defined in IEEE 802.1b, significantly reduces convergence time to a few seconds. RSTP is backward compatible with STP and is the recommended version for modern networks. Link aggregation, also known as port channeling or NIC teaming, combines multiple physical links into a single logical link. This provides increased bandwidth and redundancy. If one physical link fails, traffic continues to flow over the remaining links. The standard protocol for link aggregation is LACP, or Link Aggregation Control Protocol, defined in IEEE 802.3ad. LACP allows switches to automatically negotiate and form link aggregation groups. Port mirroring, also called span or switched port analyzer, copies traffic from one or more switch ports to a designated monitoring port. This allows network administrators to analyze traffic using tools like Wireshark without disrupting normal network operations. Port mirroring is commonly used for troubleshooting, security monitoring, and compliance. Power over Ethernet, which we touched on in a previous lesson, is often configured at the switch level. Network administrators can enable or disable PoE on individual ports, set power budgets, and prioritize which devices receive power when the switch's total PoE budget is limited. Quality of service on a switch allows you to prioritize certain types of traffic. For example, voice traffic can be assigned to a voice VLAN and given higher priority than regular data traffic. Switches use 802.11p priority tags within the 802.1q VLAN tag to classify and prioritize frames. DHCP snooping is a security feature that acts as a firewall between untrusted hosts and trusted DHCP servers. It validates DHCP messages and builds a binding table that maps MAC addresses, IP addresses, VLAN IDs, and port numbers. This prevents rogue DHCP servers from distributing incorrect IP configuration information. Let's review the key concepts. VLANs segment networks into separate broadcast domains. Trunk links carry multiple VLAN traffic using 802.1q tagging. STP and RSTP prevent switching loops. Link aggregation increases bandwidth and provides redundancy. Inter-VLAN routing enables communication between VLANs. These are the essential switching technologies you need to know for the Network Plus exam. Thank you for watching this lesson on Objective 2.2. In the next video, we will cover Objective 2.3 on wireless standards and technologies.